module has 3 pins. The center pin is VCC, the rightmost is the ground pin, leftmost data pin. We are getting digital output from this pin. It is giving you 2 parameters at output, the temperature and the humidity. The temperature range that you can measure is 0 degrees to 50 degrees, and the humidity you can measure from 20% to the 80%. And the voltage that you will supply in the middle pin is just, it can be 3.3 volt or it can be 5 volts also. So it can work on both voltages. It has a low current consumption. But let me tell you, this is not waterproof. Sampling rate is 1 Hz. It has basically 2 parts. One part is the humidity sensing component, and the second part is the NTC thermistor, alright, which is giving you the temperature. So let me explain both of them one by one. It has 2 components in it. One component is the basically humidity part, humidity sensing part. How does it sense the humidity? How is it measuring the humidity? Basically, it has one substrate. Alright, and there are 2 electrodes. This substrate is sandwiched between 2 electrodes, right? It's electrode number 1, electrode number 2. When the substrate is getting the water vapors on it, which are present in the air, water vapors in the air. Alright, water vapors present in the air. So what happens? This substrate is basically producing ions, and those ions make a path between these 2 electrodes, and the resistance between these 2 electrodes decreases because of this path, because as soon as water vapors are falling on this substrate, so the ion and these ions are created between 2 electrodes on the substrate, and the resistance between the electrode 1 and electrode 2 decreases. Alright, there is a conductive path between them and conductivity increases. The change in resistance between these 2 electrodes is proportional to the relative humidity measured. Alright, so we can say that humidity is measured is inversely proportional to the resistance. If the resistance decreases between these 2 electrodes, the humidity will increase. If the resistance increases between these 2 electrodes, then the humidity decreases. So there's an inversely relationship between these 2 electrodes. Now let's talk about the temperature part, that how it is measuring the temperature. To measure the temperature, this module has NTC thermistor in it. The temperature measured would be inversely proportional to the resistance. When there is a high resistance, then there will be a low temperature measured. To measure the temperature and humidity, we need only 3 components. First of all, we need DHT11. The second component is the Arduino Nano or Arduino UNO. It depends on you which Arduino board you are using, and 3 jumper wires. That's it, because the DHT11 module has 3 pins, so we need only 3 jumper wires to connect with the Arduino board, and that's it. Let's look at the connections. The most right pin is the ground pin, center one is the VCC pin, and the most left, this one, is the signal pin. Alright, we'll connect with the digital pin of the Arduino. So the first one, the most right one, is the ground pin. The ground pin is in Arduino Nano. Where is ground? Ground is the 4th pin over here. So first one is TX1, then RXD, then RSD, and then the 4th one is the ground pin. So this one is a ground pin. So here with the ground we are connecting the right pin. Okay, the central pin is the VCC, and the VCC I'm supplying the 5 volts from here VN, then ground, then RST, and then the 5 volts. The fourth pin is connected with the central pin, and then the left pin, the signal pin, is connected with the D2. Where is D2? D2 is just with the ground. It is just adjacent to the ground over here. Just see the TX pin, RX pin, reset pin, then the ground, and then D2, D3, and all these data pins. So we are using this D2 pins, and this D2 is connected with the MOSFET pin. To plug the Arduino Nano with the PC, we need this cable. This cable is USB 2.0A to USB 2.0 mini B cable. Let's plug the cable with the Arduino Nano, and the other side let's plug into the PC. So after plugging in the Arduino Nano or Arduino UNO with the PC, you will open the Arduino IDE. I have given the code in the description. You just go to the link and copy the code and paste it over here in the Arduino. After pasting the code, you need to add some library over here, but you need to install the library. So to install the library, I have given the library link in the description. You just go and download the library, and just you need to go to the sketch after that, include library, and then add library. And using this option, you just go to that downloaded file and double click it, and it would be automatically added over here. And after that, when this library would be added, DHT.h, then in the code you have to include it. Hash include means you are including the library DHT.dat library, that downloaded library in the code. After that, you are defining the Arduino pin that you are using to get the data from the sensor. So we have connected pin number 2 over here. So we will write basically the digital pin 2 of the Arduino to get the data from the sensor. The third line is about creating the instance for the library. It has two parts. The first part in the parenthesis is the pin, and the second part is the type of the sensor. And then there is a function, setup function over here, and there's a loop function over here. But when you power on, this would definitely run for one time, and this will continue, and this will definitely continue to run for the unlimited time. All right, so this one, for the setup, you need to basically, we are getting the serial, want to get the serial data. That's why we are beginning the serial communication at the baud rate 9600, and then DHT.begin. This is to just start and initiate the communication between the DHT sensor and the Arduino Nano. And then there's a loop function that would run for unlimited time. In the loop function, we have defined the variable h, float type, all right, and DHT.read humidity. This is the command that would be used to read the humidity data from the sensor. And then there's a little delay, okay, 1/10.1 second. And then we have defined the t variable of float type to get the temperature in it from the sensor. So we are getting humidity in h, and we are getting temperature in the variable t. These h and t would be displayed on the serial monitor. So here on the serial.print, like current humidity is equal to, this would be printed on the serial monitor, and the value will be here in h, and then the unit for h is the percentage. And after that, there is space, and then after this space, the temperature is equal to, it would be printed, and then the data that we have got in this variable, and then the unit centigrade. All right, so let's run this code. So to run the code, you need to first save the code over here, like we are saving the code, and then you need to press this upload button. The code is being uploaded by the compiler. Okay, we have got an error. I don't know where the error is. Alright, we have selected the wrong board over here. Okay, so let's go to the Arduino Nano we are using. If you are using UNO, you can select this board. We didn't select the board. This is a mistake that we made. Or after selecting the board, you have to select the port also. Okay, so now the board has been selected. Go to ATmega328 volt booter. Alright, so this is ATmega328 is our basically the microcontroller that is being used by the Arduino board. And then go to the port, select the port 5, and then press the upload button. It takes couple of seconds or sometimes a minute, so you need to wait. Alright, the code has been uploaded. Then we have to go to the serial monitor by clicking over here. Alright, so baud rate is 9600, so you have to select the baud rate over here, 9600. Now we will receive the data. Alright, so this is the data we are getting. Current humidity is equal to something, but the value is not written. The temperature equal something, the value is not written. So what we will do, that we will check the pins whether they are plugged in correctly or not. So I have connected the wiring again. Sometimes the wiring is loose, so we have connected it correctly now. Okay, let's start again. Now we are getting the data. So you can see the humidity is 56% right now here in the environment, and the temperature is 25 degrees. That is the room temperature. This is what we are getting now. See what happens if we change the temperature. Right now it is 18 to 19 degrees. Correctly 19 degrees, 19.5. Okay. The temperature is increasing, see? 20 degrees. 21. You can see the temperature change. The temperature is increasing proportionally.